The R code that I show in this video is available on Elms, and you may want to take a minute to download it and open it if you'd like to follow along on your own. In this video, we'll cover the R data type of vectors. By the end of this video, you should understand what a vector is in R, how you create vectors in R, and how operations apply to vectors in R. So far, when dealing with data in R, the data types that we've dealt with have all been scalar, or zero-dimensional. And what that means is each variable that you define holds a single value, for example, a single number or a single piece of text. R has a built-in data type for dealing with many values of the same type, and these are called vectors. What a vector is an ordered collection of zero or more values of the same data type. So you can think of vectors as one-dimensional data. Vectors can be stored in variables, just like other types of data, and we're going to refer to each member of a vector as an element. Vectors have some important attributes. First of all, they're ordered, so the order of a vector matters. The first element of a vector is always going to stay the first element of the vector unless you somehow change it. Secondly, vectors have a single data type, so every element of a vector is always going to be the exact same base R data type, like a float or a string. So how do we create vectors in R? You're going to do this using the C function. This is just the letter C, followed by parentheses. It's going to take all of the arguments that you give it and return a single vector containing each argument in the order it was provided. If the arguments aren't all of the same data type, R is going to attempt to coerce them all to a single data type. If it can't do that, it's going to return an error. Let's look at some examples in R. So remember, you can make vectors using the C function. You provided a list of arguments. R will then create a vector of those arguments exactly in that order. So here I'm going to create a vector of 2, 3, 5, and 6 using the C function. And what you can see is R returns a vector that is 2, 3, 5, and 6. Also, remember that R will attempt to convert every element that you give it for a vector into the exact same data type. So if, for example, I try to create a vector that is a combination of both floating point numbers and an integer, remember putting an L after a number tries to make it an integer, R will give me a vector, but if I look at the type of the vector, it stores it as a double because that's the lowest common denominator data type. However, if instead I made a vector that's all integers, you'll notice that when I look at the type of the data inside that vector, R tells me they're integers. Where this is most likely to come up is if you mix numbers and text. So in this case, I've mixed numbers and the letter A, and what you can see is R has coerced all of the numbers to text, and the type of my vector is now character. I've used the typeOf function to determine the types of these variables, but also it shows up in the Environment Explorer along with a listing of the members of the vector. Vectors are really useful in R. Sometimes creating them by hand can be a little cumbersome. In fact, a lot of times you might want a vector that's actually just a sequence of numbers in a row. For example, all the numbers from 1 to 10. R has a shorthand for creating such sequences, and it's just the colon. For example, typing A:B will return a vector of integers from A to B, starting with A and ending with B. Sometimes you might want to make more complicated sequences. R has a function for that as well. It's the seq function, or SEQ. It takes 3 arguments, a start, an end, and a step. So for example, the function seq 1, 15, and 3 would return a vector starting at 1 and going up by 3, ending at or before 15. The important thing to know with the seq function is it always starts at the starting number, it always goes up by the step, and it will never give you a number larger than the ending number. So if the steps take you to something that might be larger or not exactly equal to the ending number, it's going to stop before or at the ending number. Let's take a look at making some sequences in R. So recall, the sequence shortcut notation is just to put a colon between 2 numbers. So in this example, I have 1:10. What R then does is create a vector starting at 1, incrementing by 1 each step, and ending at 10. So you can see my resulting vector is just the numbers 1 to 10 in order. You could also think about making a sequence where the ending number is before the starting number. In this case, R will count downwards. So here I have a sequence starting at 1 and ending at -5, and you can see R creates a vector starting at 1, ending at -5, and incrementing by -1 each step. This notation can get a little weird when you're not thinking about integers. R's rules are that it will always start with the starting number, increment by 1, and never give you a number larger than the ending number. So if I ask for the sequence 1.5 to 3.7, what R does is it starts at 1.5, increments by 1, and gives me numbers all the way until it can't give me a number that's smaller than or equal to 3.7, so it stops at 3.5. You can make more complicated sequences with the seek function. Remember, it takes a starting number, an ending number, and a step. And what it will do, very much like the shorthand sequence notation, is it will give you every number starting with a starting number, incrementing by the increment, and giving you an ending number equal to or no larger than the ending number that you specify. So here I've asked for the sequence from 1 to 15 with steps of 3. R gives me 1, 4, 7, 10, and 13, because the next step in the sequence would be 16, which is larger than 15. So how might we use vectors in R? The real power of vectors comes when you start to perform operations on them. So mathematical operations on vectors generally perform the same operation on every element of the vector, one by one. So for example, you could take two vectors, I have written out here, 1, 3, 5, and 4, 7, 2. If you add those together, what it's going to do is look at the first element of each vector, add those up, look at the second element of each vector, add those up, and then finally add up the final element of each vector. And so it returns a vector that is the exact same length as the two that were provided. So let's look at performing some operations on vectors in R. Vectors can be assigned to variables just like other data types in R. So what I'm going to do first is I'm going to define two variables, A and B. A is going to contain the vector 1, 3, and 5, and B is going to contain the vector 4, 7, and 2. Now notice if you look in the Environment Explorer, both A and B show up there with their corresponding elements. Operations on vectors in R work element by element, trying to match them up between vectors. So if we try and add the vector 1, 3, and 5 to the vector 4, 7, and 2, R returns a new vector with length 3, where the first element is the sum of the first element of each vector, 5, the second is the sum of the second element of each vector, 10, and the third is the sum of the third element of each vector, 7. You can do the exact same thing with variables that contain vectors. So you'll notice that operation that I put up there is exactly the same as entering A plus B, which you can see again is just typing that into the console. I get the exact same result, 5, 10, and 7, because those were the vectors in A and B. This isn't just limited to addition. For example, I can multiply each element of the vector using the multiplication symbol. So again, A times B gives me a vector of length 3, which is the product of the corresponding elements of A and B. You can also use logical tests. So if I'd like to know if elements of A are greater than the corresponding elements in B, I can use the greater than sign. And what you can see is I get false, false, and true, because 1 is smaller than 4, 3 is smaller than 7, but 5 is greater than 2. I could also use the less than symbol as an example. And here I get true, true, and false. Now you might wonder what happens if you're performing operations on vectors and they aren't the exact same length. What R is going to do when vectors aren't the same length is attempt to reuse elements from the shorter vector to make the lengths match up. This is called recycling. So what will happen is R will look at the shorter vector, and when it runs out of elements, it will recycle from the shorter vector, starting at the first element and working through to the end until the number of elements matches up between the two. Now, recycling only works if all the elements in the shorter vector are used the exact same number of times. So what that means is the longer vector needs to be an even multiple of the length of the shorter vector. If not, R is going to generate a warning exception. Scalar values, so individual numbers, are identical to a vector of length 1, so they'll always be able to be recycled across a vector of any length. So just to look at this in some detail before we take it to R, if you created a vector that was 3, 4, 5, 6, 7, and added it to the scalar 5, that would be identical to adding that first initial vector to a vector of the exact same length that was all 5s. You could also think of a case where you're adding vectors of mismatched sizes. So in this case, I might have the vector 1, 2, and I want to add it to a much longer vector, which is 3, 4, 5, 6, 7, 8. What R is going to do is recycle the elements in that first vector until it's the exact same length as the second vector. So let's take a look at vector recycling in R. So in my first example, which comes directly out of the slides, what I'm going to do is take the vector 1 and 2 and add it to the vector 3, 4, 5, 6, 7, and 8. And what R will do is it will recycle elements from the first shorter vector until it matches the length of the longer vector. So again, this is exactly the same if I typed out the first vector much longer, so it had the exact same number of elements as the second vector, because R is just reusing those elements in order. Now remember, the lengths of those vectors need to be even multiples of each other. So if I extended the length of the second vector by 1, it now has an odd number of elements. That's not an even multiple of 2. So if I attempt to add 1, 2 to 3, 4, 5, 6, 7, 8, and 9, what you can see is that I get a warning message that the first vector is no longer an even length of the second vector. I'll clear my output window here. And remember that scalar values, such as individual values, are treated like a vector is length 1. So if I take this vector 3, 4, 5, 6, 7, and just add it to the number 5, what it does is it adds the number 5 to every element in that vector. That would be exactly the same as taking that vector and adding it to a vector of the same length that was all 5s. These operations also work with other types of operators. So you can think of a logical test where you're checking to see whether or not every element of a vector is equal to a particular number. We could take that same vector 3, 4, 5, 6, 7 and test whether or not it's equal to 5. And what I get back is a vector of true-false values where every value is false except for the third where the value is 5. And I get a true. Again, that would be exactly the same as testing 3, 4, 5, 6, 7, whether that's equal to a vector of that exact same length where 5 is every element. Now, all the examples that I've shown you so far have used numbers, but an R vector can hold pretty much any data type. Importantly, you can make a vector of text data. So for example, here I have a vector of 3 strings, cat, dog, and cat in lowercase. R will happily make a vector out of those pieces of text. And importantly, all of the other rules with vectors still apply. So when we get to text processing functions, you'll be able to actually process individual elements of this vector in the exact same way that you might do math on individual elements of a vector. As a quick example, let's take a look at making a vector out of something other than numbers. In this case, the example directly from the slides, where I'll make a vector containing the words cat, dog, and cat in lowercase. Again, you use the C function to do that, and R is very happy to create a vector of basically any data type. Regardless of the type of data that's in a vector, they still follow the exact same rules. So a vector can only contain a single data type, and operators and functions are going to attempt to recycle arguments. Sometimes you want to pull individual elements out of a vector. You can do this in R with what's called the bracket notation. So after a vector, or a variable that contains a vector, you put the number of the element that you would like in those brackets, and R will extract it for you. So in this case, I have a vector that's 2, 4, 6, 8. I put that in the variable A. I then use the bracket notation to say that I'd like the second element of A, and then what R gives me is 4. Importantly, that element number is called the index. So frequently when I'm referring to elements of a vector, I will talk about the index to tell you where it is inside the vector. This feature is actually really powerful. If you would like to extract multiple elements, you can actually put vectors in for the element numbers in brackets. And what R is going to do is look at every element number in that vector that's inside the brackets and extract the corresponding elements from the first vector. So here again, I have that vector that's 2, 4, 6, 8. And then I use the bracket notation to say that I would like elements 2 and 3 out of it. Then R returns a vector with 4 and 6, which are the second and third elements of that vector. So we'll do some array indexing in R. What I'm going to do first is just define a variable A, and it's going to contain the vector 2, 4, 6, 8. If I'd like to get the second element of that vector, I can use the variable A and then add the index 2 inside of the square brackets, and what I get back is 4. That's the second element of the vector A. You can do this to recover multiple elements of a single vector as a new vector by supplying a vector of indices inside the square brackets. So in this case, I'd like the second and third element of A. I supply the vector 2, 3, meaning I would like a new vector with indices 2 and 3 from A. And what I get back is that vector 4 and 6. You can repeat indices to get the same value multiple times. So as one more example, I'll take the vector A and I feed as my index vector 2, 3, and 2. What this will give me is a new vector that contains 4, 6, and 4, the second, third, and second elements of A. Vectors form the basis of many more advanced operations in R. In fact, R's computing engine is highly optimized for performing operations on vectors. Vectors also underlie many of the more advanced work that we'll do on two-dimensional data in the class, so it's good to have a basic understanding of what R is doing when it's dealing with vectors.